Hello viewers, welcome to my channel Maths with VTC. This is the right place for learning mathematics because learning mathematics is made simple here. I am going to teach you the 10th standard CBSE mathematics. The first chapter is real numbers. Before we see real numbers, let us recollect the number system you studied in previous classes. First, natural numbers. Natural numbers is denoted by n, and that set contains the numbers 1, 2, 3, 4, 5 and so on. Next, whole numbers. Whole numbers is denoted by w, and the set contains the numbers 0, 1, 2, 3, 4 and so on. When you include 0 to the set of natural numbers, the resulting set is the whole numbers. Next, integers. Integers are -1, -2, -3, -4 and so on. 0, 1, 2, 3, 4, 5 and so on. So this set of numbers is called a set of all integers and it is denoted by Z. Next, rational numbers. It is denoted by Q. Q stands for quotient. It is the set of all P by Q where P and Q are integers and Q not equal to 0. Because division by 0 is not defined, so you form all the possible quotients P by Q where P and Q are integers. The only condition is Q not equal to 0. When you form this quotient, you get two type of quotients. Either terminating like 1 by 2. When you divide 1 by 2, you get 0.5. It is terminated. Or non-terminating and repeating like 1 by 7. When you divide 1 by 7, you get 0.142857, 142857 and so on. These 6 digits are infinite times repeated. Therefore, rational numbers are either terminating or non-terminating and repeating. This you might have studied in earlier classes. Next, irrational numbers. What is an irrational number? An irrational number cannot be written in the form of P by Q. Or in other words, the numbers which are not rationals are called irrational numbers. So irrational numbers are non-terminating and non-repeating. Like A is equal to 0.10100, 1000, 10000. So every time the number of zeros increases. Therefore, it is non-terminating and non-repeating. Therefore, it is a rational number. So now, this is the real axis. 0, 1, 2, 3, 4, 5 and so on. Right hand side. Left hand side, -1, -2, -3, -4, -5. So in between these numbers, you have rationals and irrationals. So real numbers is equal to the union of all rational and irrational numbers. Irrational numbers and rational numbers, if you put together, you get real numbers. So the real numbers form the entire real axis. Prime numbers. What is a prime number? A prime number is a natural number greater than 1 that is not a product of smaller natural numbers. Or in other words, you can say prime numbers are natural numbers that are divisible by only 1 and the number itself. For example, 2, 3, 5, 7, 11, 13, 17 and so on. All these numbers listed are divisible by 1 and the number itself, not by any other number. What about 2? 2 says that I am the only even prime number. You look at the list of prime numbers, all the prime numbers are odd numbers only except 2. 2 is the only even prime number. Next, composite numbers. What is a composite number? Composite numbers are those numbers that have more than 2 factors. Our composite numbers have factors other than 1 and itself. For example, the number 6 is a composite number because it has 1, 2, 3 and 6 as its factors. You can divide 6 by 2 as well as 3 also. Therefore, it is a composite number. Example of composite numbers: 4, 6, 8, 10, 12, 14, 15, 16 and so on. All these numbers are not only divisible by 1 and itself. In between, there are divisors. So, these numbers have more than 2 factors. So, these are all composite numbers. What about 1? 1 is neither a prime number nor a composite number. This fact you have to remember. Okay. Next, fundamental theorem of arithmetic. It is a beautiful theorem in number theory. Every composite number can be expressed or factorized as a product of prime numbers. And this factorization is unique apart from the order in which the prime factors occur. Consider the number 52. It is 4 into 13 or 2 square into 13. So you can write 52 as either 2 square into 13 or 13 into 2 square. Both are same. If you forget the order of the prime factors, both are same. So in that sense, this prime factorization is unique. This you have to remember. Next, prime factorization of 72. It is an illustration. 72 is divisible by 2 because the last digit is 2. Therefore, it is divisible by 2. 36 times 2 is 72. Now you look at 36. 36 is again divisible by 2. 2 into 18 is 36. Now you look at 18. That is also divisible by 2. Therefore, 2 into 2 into 2 into 9. Again, 9 is nothing but 3 into 3. So, in summary, 72 is equal to 2 cube into 3 square. 2 and 3 are prime numbers. 2 occurs 3 times, 3 occurs 2 times. So therefore, 72 is equal to 2 cube into 3 square. Remember, you can write 3 square into 2 cube. But it is convention to write the prime factors in ascending order. So, 2 first, 3 second. Now, you look at the number 120. Obviously, it is divisible by 2. 2 into 60. Again, 60 is 2 into 30. Again, 30 is 2 into 15. Again, 15 is 3 into 5. Therefore, 120 is equal to 2 cube into 3 into 5. I have written the prime factors in ascending order. So, this is the unique factorization of 120. So, the important consequence of fundamental theorem of arithmetic is we can easily find the highest common factor and the least common multiple of given numbers. Let us recollect the definition of highest common factor and the least common multiple. It is the greatest factor present in between given 2 or more numbers. So, highest common factor is the greatest factor present in between given 2 or more numbers. What is least common multiple? It is a number, it is a least number which is exactly divisible by 2 or more numbers. So, LCM of 2 numbers means it will be divisible by both the numbers. 3 numbers means it will be divisible by all the 3 numbers. So, like that. It is the least number which is exactly divisible by 2 or more numbers. Let us find the rule to find highest common factor and LCM by factorization method. To find the highest common factor, product of the smallest power of each common prime factor in the numbers gives you the highest common factor. What is the least common multiple? To find the least common multiple, you have to find the product of the greatest power of each prime factor involved in the numbers. So, first you have to factorize the given numbers into prime numbers, into product of prime numbers. Then you can apply these rules to find the highest common factor and the least common multiple. Here is one problem. Find the highest common factor and the least common multiple of 6, 72 and 120 using the prime factorization method. So what I am going to do, first I write the 6 as a prime factorization, 72 as the prime factorization and 120 as the prime factorization. So 6 is equal to 2 into 3. Both are prime numbers. So 6 is equal to 2 into 3 is its prime factorization. 72, already we seen it. 72 is 2 cube into 3 square. That is its prime factorization. 120, 2 cube into 3 into 5. Now, to write the least common multiple, you have to consider all the factors present in all the factorization and you have to consider the highest power. Now 2 is present. The highest power of 2 is 3. So 2 cube. 3 is a factor. The highest power of 3 is 2. Therefore, into 3 square. 5 is present. The highest power of 5 is 1. Therefore, the least common multiple of 6 is 72 and 120 is equal to 2 cube into 3 square into 5, which is equal to 360. To find the highest common factor, you have to consider the common factors in all the 3 factorization. So 2 is a common factor, but what is the least power? Least power is 1. Therefore, 2 power 1. Into 3 is also a common factor. The least power is 1. Therefore, 2 into 3, which is equal to 6. Therefore, the highest common factor is 6. So this you have to remember. How to find the LCM and HCF using the prime factorization method. I already gave you the rule. Next, an interesting problem. Consider the numbers 4th power n where n is any natural number. Check whether there is any value of n for which 4th power ends with digit 0. It is an interesting problem. We can solve this by prime factorization method. Let us see how. Consider the prime factorization of 4 power n. 4 power n can be written as 2 into 2 whole power n, which is equal to 2 square whole power n, which is equal to 2 power 2n. We know the power rule. A power m whole power n, a power m whole power n is equal to a power mn. So 4 power n is equal to 2 power 2n. Now, we understand that for 4th power n, whatever the n is, 2 is the only prime factor because 2 into 2 into 2 into 2 power n times. So 2 is the only prime factor. Now, the last digit to be 0 for any number, the last digit to be 0, 5 must be a prime factor of 4 power n. 2 and 5 must be a prime factors. But here only 2 is the prime factor. Therefore, 5 is missing. Therefore, for any n, 4th power n cannot end with the digit 0. I hope the answer is very clear. Now, an interesting fact. For any two positive integers a and b, the highest common factor of a and b into least common multiple of a and b is equal to product of the numbers, that is a into b. So what is the advantage of this result? Suppose you know the highest common factor, without evaluating, you can write the LCM. Or if you know the LCM, without evaluating, you can find the HCF. That is one advantage of this formula. But for any 3 positive integers a, b and c, the highest common factor of a, b, c into least common multiple of a, b, c is not equal to a into b into c. That is the product of 3 numbers. So this result you have to remember. It is applicable only for 2 integers, not for 3 or more integers. Okay. Now we are going to see exercise 1.1. The first problem is express each number as a product of its prime factors. It is very simple. Let us see the first problem. 140. 140 is divisible by 2. Therefore, 70 into 2 is equal to 140. Again, 70 is divisible by 2. Therefore, 35 into 2 is 70. Again, 35 is divisible by 5. Therefore, 7 5s are 35. Now, the prime factorization of 140 is 2 square into 5 into 7. Remember to write the factors in ascending order, increasing order. Okay. You can divide 140 first by 5 and then 7. Whatever order you can divide. But the thing is, when you write the answer, you write the prime factors in ascending order. That is important. Okay. Next, 156. Obviously, it is divisible by 2. So, I divided by 2. 78 is the quotient. Again, 2 is divisor. When you divide 78 by 2, you get 39 as quotient. 39 is divisible by 3. 13 times 3 is equal to 39. 13 is a prime number, so we have to stop here. Therefore, the prime factorization of 156 is equal to 2 square into 3 into 13. Okay. 3825, third sum. Obviously, it is divisible by 5. So, I divided by 5. The quotient is 765. Again, I divided by 5. The quotient is 153. It is divisible by 3. To find a number is divisible by 3, you simply add the digit. 1 plus 5 plus 3 is equal to 9, which is divisible by 3. Therefore, 153 is divisible by 3. So, I divided by 3. The quotient is 51. 5 plus 1 is equal to 6, which is divisible by 3. Therefore, 51 is divisible by 3. I divided by 3. 17 is the quotient and 17 is the prime number. Therefore, the prime factorization of 3825 is equal to 3 square into 5 square into 17. Now let us consider the fourth problem. 5005. Obviously, it is divisible by 5. Therefore, I divided by 5. The quotient is 1001. Remember, 1001 is a symmetric number. When you read it from left hand side or right hand side, it is same. So, sometimes, not always, sometimes this number may be divisible by 11. So, I tried with 11. 91 times 11 is equal to 1001. Again, 91 is divisible by 7. Therefore, 13 times 7 is equal to 91. There ends the process. Therefore, the prime factorization of 5005 is equal to 5 into 7 into 11 into 13. Now, you look at the last number. 7429. Obviously, it is not divisible by 2. 7 plus 4 plus 2 plus 9. It is not divisible by 3, therefore it is not divisible by 3, not divisible by 5, and so on. I tried with the prime numbers before 17, but only 17 divides 7429. So 437 times 17 is equal to 7429. Again, 437 is divisible by 19, 23 times. 23 is a prime number, therefore we have to stop here. The prime product of 7429 is equal to 17 into 19 into 23. Okay. Now, applying this prime factorization technique, we can find the LCM and HCF of numbers. And now we are going to verify the fact also. LCM into HCF is equal to product of the two numbers. First problem, 26 and 91. So 26 is equal to 2 into 13. 91 is equal to 7 into 13. Therefore, LCM, we have to consider all the factors with the greatest power. So 2 is present, greatest power is 1. 7 is present, greatest power is 1. 13 is present, greatest power is 1. So the LCM is equal to 2 into 7 into 13, which is equal to 182. And HCF is equal to 13. That is the only common factor. Therefore, HCF is equal to 13. Product of LCM and HCF is equal to product of 182 and 13, which is equal to 2366. This you can verify. Similarly, the product of the numbers 26 and 91, that is also 2366. You can verify this. Hence, LCM into HCF is equal to product of the two numbers. For the first problem, it is verified. Now you look at the second problem. 510, which is equal to 2 into 255, which is equal to 2 into 5 into 51, which is equal to 2 into 5 into 3 into 17. Therefore, that is its prime factorization. For 92, it is 2 into 46. 46 is nothing but 2 into 23. Therefore, its prime factorization is 2 square into 23. Now, to write the least common multiple, you have to consider all the factors with the greatest power. So, 2 is present, greatest power is 2, 2 square, 3 is present, greatest power is 1, 5 is present, greatest power is 1, 17, 23. When you multiply all these factors, you get 23,460 as the least common multiple. What is the highest common factor? Obviously, 2 is the only common factor and its least power is 1. Therefore, the highest common factor is equal to 2. Now, the product of LCM and HCF is equal to 46,920. Let us see the product of the numbers. 510 and 92, which is equal to again 46,920. Therefore, both are same. Hence, for the second problem also, the result is verified. That is, LCM into HCF is equal to product of the numbers. Third sum. 336. Its prime factorization is 2 power 4 into 3 into 7. This you can verify. Similarly, prime factorization of 54 is equal to 2 into 3 cube. Now, what is LCM? Consider all the factors with the highest power. 2 power 4 into 3 cube into 7, which is equal to 3024. And HCF is equal to common factors only with the least power. So, 2 into 3, which is equal to 6. Product of LCM and HCF is equal to 18,144. At the same time, product of the numbers also 18,144. Hence, for the last sum also, the result is verified. Next, third sum. Find the LCM and HCF for the following integers by applying the prime factorization method. 3 numbers are given. Okay, let us consider the first problem. 12, 15 and 21. 12 can be written as 2 square into 3. 15 can be written as 3 into 5. 21 is nothing but 3 into 7. So, these are the prime factorization of these 3 numbers. You apply the rule to find the LCM and HCF. LCM. Each power, each factor, you have to consider the highest power. 2 is present, highest power is 2. 3 is present, highest power is 1. 5 is present, highest power is 1. 7 is present, highest power is 1. So, 2 square into 3 into 5 into 7 is equal to 420. That is the least common multiple. And the highest common factor. 3 is the only common factor. In all the 3 factorization, 3 is the only common factor. Therefore, HCF is equal to 3. Now, you look at the second problem. 17, 23, 29. Obviously, all are prime numbers. So, 17 you can write 1 into 17. 23 you can write 1 into 23. 29 you can write 1 into 29. Therefore, the LCM is equal to 17 into 23 into 29 into 1. That is equal to 11,339. You need not write product 1 because it will not change the number. Therefore, the least common multiple is just the product of the 3 numbers. Then what is HCF? The common factor is only 1. No any other number. So, when the given numbers all are prime numbers, then the highest common factor is always 1. So, in order to ensure that, I have written the prime factorization as 1 into 17, 1 into 23, 1 into 29. Now, you can understand the highest common factor is equal to 1. Now, you look at the third problem. 8 is equal to 2 cube, 9 is equal to 3 square, 25 is equal to 5 square. Here, the numbers are not prime numbers, but the prime factorizations are different. 8 is equal to 2 cube, no any other factor. 9 is equal to 3 square, no any other factor except 3. 25 is equal to 5 square, other than 5, no factor. Therefore, the least common multiple is equal to 2 cube into 3 square into 5 square. Just a product of the numbers, which is equal to 1800. Then what is the HCF? As I said, it is 1. Because it is 1 into 2 cube, 9 is equal to 1 into 3 square, 25 is equal to 1 into 5 square. So, in all the prime factorization, 1 is the common factor. Therefore, highest common factor is equal to 1. Given that highest common factor of 306 and 657 is equal to 9. Find the LCM of 306 and 657. We know the result. LCM into HCF is equal to product of the two numbers. Therefore, LCM of 306 and 657 into HCF of 306 and 657 is equal to product of 306 and 657. This rule already we studied. This result already we studied. Therefore, we have to substitute highest common factor is equal to 9. After rearranging the terms, you will get LCM is equal to 306 into 657 divided by 9, which is equal to 22,338. So, using that result, without evaluating LCM, we can find the LCM. That is the advantage of that result. Check whether 6 power n can end with the digit 0 for any natural number n. Already we studied 4 power n. Here it is given 6 power n. Let us see how. Let us consider the prime factorization of 6 power n. 6 power n is equal to 2 into 3 whole power n, which is equal to 2 power n into 3 power n. Again, here 5 is not a factor. If the last digit is 0, definitely for that number, composite number, 2 and 5 must be a prime factor. But here, 2 is the only prime factor, 5 is not present. So, the last digit to be 0, 5 must be a prime factor of 6 power n. But 2 and 3 are the only prime factors of 6 power n for any natural number n. Hence, for any natural number n, 6 power n cannot end with the digit 0. Sixth problem. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. You remember the definition of composite numbers. It can be written as product of smaller numbers. Let us see how. 7 into 11 into 13 plus 13. Two terms are there. In both the terms, 13 is common. So, you take 13 common outside. Then the first term, you get 7 and 11 as the remaining term. In the second term, 1 is the remaining term. Therefore, 13 into 7 into 11 plus 1. 7 into 11 is 77. 77 plus 1. Therefore, the given number can be written as 13 into 78. That is 13 into 6. Therefore, you can write this as 2 into 3 into 13 into 13. So, 2, 3, 13 are the prime factors of the given number. It is a composite number. Similarly, you consider the second number. 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Two terms are there. In both the terms, 5 is a common factor. So, you take 5 outside. The remaining factors you write inside. In the first term, it is 7 into 6 into 4 into 3 into 2 into 1. In the second term, it is simply 1. Therefore, it is 5 into 1008 plus 1, which is equal to 5 into 1009. 1009 is a prime number. So, the given number is a product of 5 and 1009. It must be a composite number. Now, you look at this problem. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point at the same time and go in the same direction. After how many minutes will they meet again at the starting point? Now you look at the diagram. You suppose that it is the circular path in a sports field and the dot is either Sonia or Ravi. For one circle, Sonia takes 18 minutes while Ravi takes 12 minutes. So, for that point, Sonia comes back to 18, 36, multiples of 18 minutes, she will come back to the same point. The same time, Ravi comes back to the same point in multiples of 12 minutes, 12, 24, 36 and so on. So when they will meet again at the same point, if the minutes is a common multiple of 18 and 12, they will come to the same point. So that is the idea. Sonia will come to the same point in multiple of 18 minutes, while Ravi will come to the same point in multiple of 12 minutes. So they will meet at the same point when the time is both multiple of 18 and 12. Hence, we have to find the LCM of 18 and 12. To solve this problem, we have to find the LCM of 18 and 12, and it is equal to 36, because 18 is equal to 2 into 3 square, 12 is equal to 2 square into 3, least common multiple of 18 and 12 is equal to 2 square into 3 square, which is equal to 36. Therefore, after 36th minute, both Sonia and Ravi will meet at the same point. Okay? Thank you.